Hello everyone, welcome back to 13 Day, and today we're going to talk about the expected expected ex, ex, you know what? It's a mean, okay? And variance and standard deviation. Expected, yeah. All right. A person may buy a lucky tickets for $1 and have 20% and chance to win the $2 and 5% chance to win the $11, and otherwise they lost. How much would they expected to to win or lose per game, and then the long run? Okay. So first thing first, we have to write something, which is like we can say um, the probability of the if you lose the 1 mark, if you lose $1, it's a -1. And so we say maybe the probability equal to -1, and the probability of the pay equal to $1, which is because you won $2, which is you add 1 plus 1, and probability of the pay equal to 10, which is you win $11 because you 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 pulled the $1 in and you have to win $10 pretty much. This is how you win $1, $10, and lost $1. Yeah. Um, that's it. And what we do is we get this part, and then now we're gonna say how to win this long run. So first thing first, we could create a table. So it's like this. Yeah. So we say P, and this one's P equal probability of P equal to P. And so -1, 1, and 10. So 0.05 is 10 because this is 5%. And 0.75% is to lost the $1. And 0.2% is win the dollar. So in total is $1. So we had play maybe like we say 1,000 times, maybe 1,000 times. And if you had 1,000 times, 750 times will be loose, and 200 times will get $1, and 50 times will win the $10. So this is the ratio. And now what we do is we're gonna use our mean equal to the -1 times 175 plus 1 times 20 and plus 50 times 10 and divide by 1,000. So you can say this is -1 and plus 200 plus 50, so which is equal to -500 and 1,000, so that equal to negative. So which is 1,000 and plus 20 250. Yeah, so that's a -500 divided by 1,000, so this is negative 0.5 and negative 0.5. So we say negative 0.5 dollars lost per game. Yeah, so that's pretty high ratio loss. So we can say you lost 50 cents per game, and then the ratio is negative 0.5. So you lost 50 cents per game. That's very, very big one. So you can say, do not try to take a risk. And this is expected values and for the summary for the product. And yeah, and this is the main, which is we're using Greek letter mu. And the coin which is around this area, and pretty much we need to know. So we got the 0.6, we got the for any single toes for 0.6 and toes the results noted, and also x is summer of the head, and 3 toes is enough, and that's pretty much the given. Okay, first thing first, we need to follow up this one. So we need to find our mu first. So that equal to e to the x, equal to x times probability of x. Okay. So we can find the least outcomes simple space and to determine this one. Any single total 0.6 heads. Okay. So if no heads, 3 toss no heads, what's the 1 divided by 8 and times the so which is so which is the x and probability of x. So we say 0, 1, 2, and 3. Okay, so first one, we need to figure out our heads on any single toes is 0.6. So which is, if you know heads, there will be 0.4. So 0.4 times 0.4 times 0.4. So it's 0.064. Yeah, heads is 0.6, tails is 0.4. Yeah. And ones, which is you say 0.6 times 0.4 times 0.4. So we say, sorry, tells 0.4 times 0.4 times 0.6. And that equal to 0.288. And two heads will be 0.6 times 0.6 times 0.4. And that's around 0.432. And all these heads will be the end of 0.216. Yeah. Okay, now what we do is we multiply by these things. So 0 times 0.064 plus 1 times 0.288 plus 2 times 0.432 plus 3 times 0.216. And then 0.288 plus 0.842 plus 0.648 equal to 0.8, I guess. And then, so this is how you do the question. And then I'm going to show you the expect values for this one. Now we using our ideas to find 3x plus 1 is. So I'm using that ideas. So I'm just moving up a little bit. So question E, 3x plus 1, so equal to 3x plus 1 times px. So first one, so 3x plus 1 will be 3 times 0 equal, so 1 times 0.046, plus 3 times, so it's 4 times 0.288, plus 7 times 0.432, and plus 0.216 times 10. And that equal to, use the CAS calculator, and then we calculate it, and it's 6.4. Yeah. And if that's a square, so we do that one during the class, please. And basically that's how we do the question, like that. Last question for this. So we read the 5 monthly fee, and also we have one service and for 0.05, and that's 0.01, and then 0.01 probability 3 or more for 0.00. Okay, so let's create our course. Yeah, so course and G and probability of G equal to G. Okay, so that's it. First one is 0, so we got $5, and which is 0.94, because you say if you have 5 like 0.1s, and then that's how you create. And if you have a 1 call, you need to have negative $35. Because each call or repeat was like 40 bucks, and 5 bucks for fee, and then 2 calls will be negative 75. Yeah, because you are minus that 5, so that's 0.05, that's 0.01, that's 0.00 if greater than 3, greater than equal to 3. Yeah, so that's it. And what we do is, I'm sorry, my Mac is going crazy. So, and what we do this question, and we need to figure out this G equal to 2 cos phi G equal to 0, because this TV company is like such the contact, and then we do G times probability of G equal to G. Yeah. And that equal to 5 times 0.94 minus 35 times 0.05, and minus 2 times, sorry, minus 75 times 0.01. And that equal to 2.2 actually. So this means like $2.2 per month for the contract sold. Yeah. And I will show you how to do this question later on as well, because this is pretty important questions. And we do actual examples in the next video. Okay, so stay with me and see you guys next time.